Hello and welcome to Perl Weekly Challenge Club in APL. My name is Richard Park. I'm not going to do much ado. I've been doing the Perl Weekly Challenge in APL for quite a long time now, but I took a big break and then I've sort of come back since I've managed to find a little time to squeeze them in. They're not generally super challenging. I mean, they're a challenge, but they're not super long tasks. The idea is you can keep it up. They are principally designed, or the site is sort of a Raku programming language promotion thingy, but there are lots of these so-called guests, which are people solving the problems in all kinds of programming languages, and I see Connor Herkstra do them in BQN. And yeah, I'm going to show you going to try to do some here on a recording in APL, but let's see how far we get. Right, so we got two tasks as usual. Balance string max score. Yeah, okay, interesting. Balance string made up of lowercase English letters and digits. Format the given string where no letter is followed by another letter and no digit is followed by another digit. Always return the lexicographically smallest arrangement, empty string if it's impossible. So this is a shuffling. Okay, so it's 3, 4, 2. So what I've taken to doing recently is utilizing the autocomplete that paren load gives you, and then going to the front and using then link. Oh, that's fine. I believe this will be me. Is this big enough? Is it a little squidgy? I'm going to pause this for a second just to check something. Yeah, okay, so we're going to start with creating our function, balance string. And this is going to be a little defen here. And then I guess we'll just put all the test cases in. It's usually what I do at this point. So we're going to say our tests are going to be that if something doesn't match balance string of this input, then suspend. And that's the output. Same again. I wonder if I could write a script to write these tests for me. I'm not going to do it now. Yeah, this is the slightly tedious bit. Ooh, yeah. Yeah, we're doing a. Oh, did I do that? Yeah. We're doing a sort of experiment here to see whether, as well, it's worth me just. I mean, you can press, if you're watching this on YouTube, you can just press L to skip forward 10 seconds. You can skip a bunch. If enough people see this and skip, then you get the little thingy that shows you, the most popular parts of a video. Pardon me. Right. So currently these all fail. That's fine. Yep. Now we can go in. This is a thing I'm also going to be curious about in terms of showing this as a thing, is this having a defen inside a defen and then editing it as we go. Right, anyway, the point is no letter followed by another letter, no digits followed by another digit. Makes it bigger for you. Okay. So if we want, like, we can have our letters, which is just the alphabet, and our digits is just quad D. Okay. Then is this what it is? Omega. Now I'm curious. Basically, I'm thinking it's about rearrangements. And if you've seen any of the idioms that basically involve grade, especially like ranking and stuff like this, you'll know that there are interesting ways to manipulate memberships. Oh, there's one there. So that you can rearrange a list, a string in a certain order. So I'm wondering whether something like this, where we're creating an arithmetic so that, now of course the interesting thing here is, what is it, the expected answer is, oh, it's the followed by is going to give me you know, ensuring that these are separated. Now this is actually the opposite, isn't it? Now if I grade this, I'm going to get a sort order to ensure they are next to each other. So that's the exact opposite of what I want. But I feel like this is along the lines of how we would do this in APL. So what's the issue? Currently it's in order, but you need the lexicographically smallest. And how would that work? Yeah. Well, they're implying digits come before characters. I don't know if that's a universal rule. Otherwise, it's like a loopy thing. Yeah, I mean, here's the other funny thing about deciding to record this week in particular is it is significantly harder than the previous few weeks I've done. Or at least the answer isn't coming to me straight away. Sometimes it's worth going to the next one and coming back, but we'll see. Yeah, max score might be more straightforward, but let's have more of a think. What sort order would cause them not to be? This groups digits and letters. Is it going to be something like scans? Kind of. I mean, this would be relevant if we were sorting ABC 1, 2, for example. What? Yeah, or something like this. Ooh. Basically, the 1 and 2 multiply is about making the scan here. So my thinking is the scan is about making elements within a category distinct, so they're sorted separately from one another, and the multiplication is about separating the types. I don't believe in this at all. I mean, this is just throwing crap at a wall. And what would sort it? A1, B, 2, C. It's just as a permutation. It's not the rank. Of course not. It's like we need the rank of this. Yeah. You have to assign a score based on whether something's a character that's been seen yet or a digit that's been seen yet. And this is what I mean. The scan, is it a horrible idea? And this will rank. There's some way of combining this. What are we after again? That basically says, why would you be 3? That basically resets something like this. Resets when we hit a digit. It's really but it doesn't quite. It's not a flaw. It's not a. What I'm imagining now is that we got as far as we've got the 1. We've got the 1, 2, 3 from the characters. We've now got a 1, 2 from the digits. And that basically does it. A1, B2, C. I mean, is it the minimum? Or is that just a lucky coincidence? The zeros throw that off, of course. The minimum non-zero digits. The minimum non-zero numbers. That's a problem I've not seen before. Zeros shouldn't count. Could be some kind of arithmetic-y way to do this. I mean, okay, let's just get something in for now. So zeros get the maximum value. Now when you min them, you get what we're after, that you can grade and you can index. And it's a little bit mashy in my opinion. I'm not super convinced by the whole thing, but to see it fail initially is to do with the lexicographicalness, because it says it's the same. And the only way to change that would be just swap around, because grade is stable, so on a tie break we keep the original order. That's not it either. Oh really? So it wouldn't matter. What's it sorted anyway? Puts the digits first, which is what the implied answer is. Can't do that, that's not right. I was like, let's just sort the whole thing, right? But again, I think we're fooling ourselves. That's even worse than I thought. Forgetting to grade, of course. Why do we think we're fooling ourselves? Because now the original order doesn't matter. Or does it not matter? Format. So that no letter is followed by another letter. If there are multiple valid rearrangements. I mean, there's nothing to say that the original order matters at all. Okay, maybe it doesn't. Yep. No. Really? What's this? Not A2B1C3. Sorry, what's it complaining about? It's complaining that not A1B2C3 doesn't match the answer. I think that's just a defense thing, not a defense thing. Eh? Oh, they're all over the place. Yeah, is this another like specification issue? Could well be. Like, what's lexicographically smallest about this? Is it saying it's not? For some reason, it's just saying, oh no, it's not all digits. Yeah, 0 is less than A is less than 1. Right? Oh, but also you just can't have those characters, those next to each other. I understand now. You must use... Yeah, definitely coming back to that. And probably abandoning this video. Max score. Same again then. So I write my tests that say 4 does not match the max score of 0011. Suspend if 3 zeros. It's a string. Yep. 1113. That's 3 as well. Uh, 30101. And 5011101. Okay. The maximum score after splitting string into 2 non-empty substrings. Score after splitting the string is the number of zeros on the left plus the number of ones in the right. And this is all substring splits of at least 1. So it's something like what would all the splitting vectors look like? We would have the 1 1 on the head, 1 0 1 0 1 0 0 1. In this case, that's it, isn't it? It still says that there are just 3. But it's not a simple rotation. If you've got A, B, C, D, E, it's the head split, then it's a 1 0 1 split, then it's a 1 0 0 1 split. And what is that? 1 1 1 0 1 1 0 0 1 up into the length. That's all it is. Ooh. Now that's interesting. 12 to 9. 9, 10, 12. Or like an expansion, so it's like, it's 1, 1. No, that's it's the exact same pattern you'd have to regenerate. So it's not that. It's what exactly? Yeah, it's something. It's something. Right. 1, comma omega zeros, comma 1 for each of those. I mean, this is grim. Okay. My keyboard had a little glitch. Yeah. I to make 1 plus. Right. Yep. Omega. Partitioned by each of these. What? Yeah. What? Oh, it's the APL, it's the dialogue style partition. And then the kind of ugly way to do this. What's the score again? 0's in the left plus. What? Okay. What? Oh, 1's in the right. Okay. 0, 1. Oh, that's interesting. Does that really work? That's 0's along the second axis. Is 0's in the left. 1's on the right. And that's the same as rank 1? That is. Wow. Isn't that interesting? So, it's a solution. Not the happiest with it. And then what? Max score. Okay. What does it think? Oh. Yeah, exactly. Right, so my main issue, you see me typing around like this, is that for some reason the debugger, it doesn't really update. It's sort of already fixed MS. We go into the broken one, we edit it. When we come back out, the MS that every other call sees is still the old one that doesn't work. So you have to come all the way out the defun and then just run it again. Alright, if these all pass, then let's just say all tests pass, which it does. We can come back and think about neatening this up. But first we need to try and balance the string. Yeah, it is BS. Okay, so another way is to 1 potato, 2 potato it. And that is to say, oh, we're going to take, that is to say, if we find the first thing, where does it rank? No, it's something like that. It's like, so if we look at ABC 1, 2. Um, well, how would you know in advance it's the distribution, is it? Can you, is that worth computing ahead of time? The distribution of ones and of letters and thing and characters like must be exactly one apart. Okay. So letters of characters, the difference of that, the absolute value must be equal to 1. Otherwise you can't intersperse them. If they have the same number, or A1, B2, no, okay, they can have the same number. But it must be 1 or 0, not 2. Yeah. Okay. So if that's not the case, we just return an empty character. Empty character vector. So that applies to, for example, 1A23. Then we can sort them lexicographically. A, B, C, 1, 2, as in we can sort we can sort and then put in order of the larger one. What does that mean? We can then sort. So first we sort them, then we know we have the lexicographically smallest arrangement. Then we're going to reorder so that the largest group comes first. Within these groups. And how does that work? Does this just work? You just do the order is this. We've got the letters, we've got the digits. We do the digits letters and digits times the order. The higher one comes last, depends how you're sorting it. No, wait. Oh, I see. It doesn't matter. Just stick them. It's letters and digits, right? Okay. Do a better version of this another time. It doesn't even do what I said I wanted to do. No, because we're grading the wrong way. Okay. And then we can finally do all of this stuff. Yeah, you want B2C3. Okay, so I think that's the solution. I just need to sort of arrange it by explaining it, I guess, so that we can get it to look decent and potentially reduce some things. So we have it sorted. Then we want the membership of letters and digits. Then our merge order is letters and digits is the merge order makes sure that the largest contingent comes first, which is the letters times L times the sum of L plus the digits times the sum of digits. Then this bit, which frankly I would happily love to redo this part because I'm not hugely keen on it, but it works for now, which is we're gonna say, what do we call it when we're taking the 0 values and converting them to the maximum? It's like max zeros or ignore zeros. Ignore 0 means put the maximum possible representable value at where the zeros are, so that we can take our argument and sort it according such that it's the minimum of plus scan L min over ignore 0 plus scan D. It smells like this is it, but I'm not sure. Well, it fails immediately. Really? Could be... No, really? These have even contingents. So therefore the reordering puts... Oh! No, the reordering puts digits first. I've just been... You're supposed to do this to the sorted. It's actually sorted in merge order according to this. I'm not sure. Oops. Oh, you gotta recompute after doing all this arrangement. You can't reuse those. That's sad. Okay, that's fine. So sorted merge order becomes ordered. And we're gonna take ordered stuff. We have to do these. We have to recompute. When do we ignore the 0? It is then, isn't it? Yes. Digits. Then grade up. Then get the order. It's not. It's not O. It's O. It's not. Yep. It's O. The ordered input. Pre-ordered. The merge order. The pre-order. This isn't even really close, is it? Oh, this has the same mistake as before, which it shouldn't do because of the merge order stuff. Why'd you say that? Really? Oh, because it's not omega, it's sorted. You keep forgetting to use your stuff. That ain't right. Really? You're saying this is ordered, that's not ordered. 2 reasons. Yes. Right. So essentially this should keep it in the same place. No, it doesn't. Why? Why? Because it's the sorted one. Wait, what? This is just wrong anyway. What? If omega starts with ABC and sorted version goes 1, 2, then L should be 0, 0, 1, 1, 1. Which is not. Why is it not? There's a global L somewhere that's not being it's not being signed. Oh, it gets a lot further. Oh, we can do our 1 is less than the difference sum, then return empty. Oh, really? Oh, the nested defen scheme. Oh my. Aha. Well, I think we know. What? Oh, we know nothing. Yeah, I want to save the changes. Why are we stuck? The console isn't reporting anything. Yeah, I mean the video is definitely a wash. Gonna abandon that. Could we cut it? Maybe. I'm now just having a ride. Nightmare. Continue. No. It's not even getting that far. Oh, we'll be back. Try again. G Perl Weekly Challenge 342. Done it wrong anyway. On the wrong week. I think. Directory was created. I was on the wrong week the whole time. So now I have to go. Yeah. Go into my file explorer. Let's find. Perl Weekly Challenge Club. I think I must have put it into here. Yep. Balance string and max score. Come out of here. Go into the next one. Find me. There it is. Go away. There we go. Did we do it? We did it. All tests passed. All right. Wow. We did it, guys. Is there anything I can do to reduce the amount of faff here? Really not sure. We bring it in sorted. We look for letters and digits. If there's a difference of greater than 2, if there's a difference in the number of letters and digits greater than 1, we can't do it, so we return an empty string. We can't intersperse them in the way the problem describes. Then, to ensure that they are interspersed correctly, given the stable sorting of grade, we arrange them so that if there are more letters, the letters come first. If there are more numbers, digits, the digits come first. Put them in that order. So they're lexicographically sorted within digits and characters, and they're sorted so that either all the digits or all the characters come first, depending on which there are more of. Then we want to ignore zeros when we're comparing letters and digits for the final sort order for the interspersion. And that final sort order is computed with just a plus scan. Oh, maybe it's fine. Okay. Don't know. So yeah, open questions. Am I publishing this? Am I editing it? Cut this, cut this, cut this. And finally, some kind of conclusion. So yeah, let's take a look at our final submissions here. Number week 34 in APL. We can stick sort of left and right, can we? Yeah, again, reading the max score, it just feels likely that it can be sort of tightened up a little bit. And I don't mean even trivial things like just spelling and stuff. I gotta say, it's not bad, except an intermediate defen always smells notationally less fun. So I don't know. Yeah, I mean, I'm happy that I solved the problems, but I think I have a couple of notational philosophical questions coming out of this. You know, there's a lot of arbitrary choices you have to make writing APL solutions. So, for example, we've got choice of like sort of more verbose, more descriptive names versus sort of one-letter names that make it feel more like you're using a notation, a mathematical notation or something. And then, should I break this up? So that you've got instead it's the max score. Its length one plus type omega. Is it length? It's parts pvex 1, comma some number. All right, yeah. I mean, is it more APL? Has to be like n replicate each 0, 1 comma each, 1 comma swap each. These are the pvex, and then the partitions are the pvex partitioning omega. And then it's the max sum each, not 1, equal to the parts. Is that nice? I don't know. All right, so one thing is, I guess, one advantage of the little defen is that at least it kind of shows you what the structure is we're after in each case. Neg 1 plus iota. And then it lets us put that all in one line. Maybe that's nicer. Maybe that's a more manageable number of thoughts per line. Yeah. I mean, let me know what you think of these solutions, and I'll be very interested to see other solutions, in particular to the balanced string. The max scorer kind of took it quite literally, and part of me wonders whether, based on everything seen here, there's a more direct way to compute. Since we're only interested in the scores at the end of the day, we probably don't actually need to create these partitions and then do the comparisons and all the summing. We can probably work out based on these partition vectors, almost use them as masks in some way. And then, or do like an old school partition sum idiom using the masks, using the partition vectors and converting these into actual booleans. And it's probably way more efficient. This one, the only thing I'd be really happy about is if there was another way to compute the interleave order without having to do this ignore zero thing, because it feels like a bit of an ugly hack. I don't know how to do that off the top of my head, but I do know how to approach the max score thing. Okay, yeah, I had to go do some stuff, but now I'm back, and we was going to look at what? Oh, so I lost so I lost all that stuff I was doing. When just before I went away. It's a shame. Did it help? I think it did. I think it made it a bit nicer. So we said it was the partition vectors were from making the pattern of ones and zeros out of iota count omega. Partition vectors makes a patterns of ones and zeros up to the length of the thing we're trying to partition, which is our argument. Then our partitions are just doing the partitioning. Dialog style rank 1. Oh, yes. Then the rest is as as we had it. That's really interesting. Why can't it reformat? That usually means there's a brace or bracket. If I take all of you. That's so deeply interesting. Why is it like this? Meto, what? It's gonna be a weird character in it? No. This is horrible. Are you serious? Okay, I can make some changes apparently. I must have entered a dodgy character by accident. And we don't need to mix if we do rank 0. To make 1 plus omega parts still. The partition is still partitioning. Okay. And then we compute the max sum of zeros and ones in each of the parts. Blah, blah, blah. Okay. We're happy. But we wanted to do a more efficient version and do a little timing for fun, which is that we suspect our partition vector can be the exact same thing, but as long as we length omega take each. No, we don't need to do that because it's already going to be that wide. Then it's the apple cart partition sum of each subvector of n indicated by AV. Fast this, that's what I'm after there. Another small philosophical point of recent consideration. The original idiom lists were not copy-pastable. I mean, they weren't copy-pastable because until they were published digitally. But what I mean is they were expressions involving named arguments often. Whereas modern apple cart is designed so you can just copy and paste a function, put your arguments either side, and boom, bam. But then it's very obvious you've been doing that. The ideal way to use them, then, I think, might be you look at the function or expression and then use it, decompose it so that you can use it as a direct expression in your own code. So in this case, we've got a partition, or in this case, we might not be able to on account of the rank thing. So maybe it won't matter anyway, but we'll see. Maybe we'll make a third version with that consideration. Right, so the point is, partition vector sum of execute omega. Oh, but the partition. Oh no, it's. Sorry, my point is, we want to make the partition. Not one, not one, not. Right. Right now what we do is some partitioning, then some scalar extension. I mean, it's not a bad solution if I say so myself. Then sum each and find the max. Of course, that's over all partitions. It's just for a single one. The thing is, now what we have to do that's clever, if we want to try and use, I thought we're just adding up this stuff partitioned, right? So you take this, so the sum each partitioned of this. Yeah, this is the bit we're missing. So essentially, we can substitute wholesale in this for. What is that? Oh, sorry. Right. We can substitute the plus slash and the partitioned each with this, right? And that works. But what we're actually after is a not after the partition. Well, that's exactly what we need. So we're going to execute our input string to get a Boolean vector. We're still going to have computed the partition vector as before, but essentially we need, what's the easiest way to do this? It's always going to have exactly 2 1s. Nah. Sorry, I'm just trying to think what's like the nicest way to only have after the second one turned on. Why y. That is this, isn't it? That does involve a scan. It's an interesting question. It's a bit micro-optimizy. I had thought something like that. But maybe where we are rotating, basically turn all one after that, then invert it. So we know that we can turn on ones after the first one, which if we reverse becomes before the last one, and then do some inversion. The not equal scan is nice because we know we only have 2 ones in our partition vector, and so therefore when we do the toggle we get the single collection that we want turned on. That's always at the beginning, and then we just invert that to get the end. Why? Because we want to take our Boolean vector and do not at these indices of the partition vector on the Boolean vector. Then we can do our partition sum. With our partition vector, and that is really close to this, but I guess I've got them the wrong way round, is it? It's zip, sorry, max score 0's in the left. Oops. Then it's just the toggle. Yeah. Okay, and then the last thing is to see whether we can do this in a slightly more performant way, which I'll talk about after I've typed this up and tested it. Huge question. So can we toggle at these locations in yeah, so what I'm imagining is what I'm imagining, yeah, I mean, okay, we can solve for, we've already solved for one partition and our input, and so we're just gonna do the whole shebang rank 1. So neg2 minus slash 0 catalate with 1 rotate of alpha, compress the plus scan of omega, the plus scan of omega being the plus scan of not at the first portion of alpha in omega. Okay. Really? Oh, forgot to max sum it. Yes. So I do the max sum. I'm suspended. I exit. It's not got the correct MS because it has to redefine it. Because it has to be the maximum rather than the minimum. Okay. Can't be right. That says 4. 4 matches that. What? Four matches that. Yes. But when I come out, it says no. Yeah, I don't know. I'm going to have to figure that out. Also, stuff's starting to chug. Whatever. Point is, we did it. Okay. Yeah, I'm going to have to pause this and come back when I can test. Right, the last version I want to write before I move on with my life is one that puts the looping inside. So we still have B and P. Oh, we can just step through. Okay. We want to do the last one, I think. It's the most interesting. PVAC we're happy with. Okay, the question is, can we toggle at where not equals scan PVAC rank 1 execute each omega? No. This is wrong? No, it's happy with that. That's an interesting pattern there. That's an interesting pattern I could probably exploit. Uh-huh. Is this what they call the APL way? So now it's a jot. Well, no. Yeah, I mean, sometimes it's jot dot greater than selfio of 4. Greater than equal to 1, 2, skip a few. Okay, I don't know. It's getting too interesting now. So what I've got to do is also write a version that exploits that. And probably do it a different way than this. Or I can define that once. No, because we need the length. This outer product is not going to be optimal. It's still going to be faster than what we're currently doing, but anyway. So yeah, so that's something by 6, and omega is 6. Can we toggle at... Oh yeah, this is the problem. You can only toggle at alpha omega rank 1 execute each omega. Toggle at where alpha. Yeah. This is the booleans we're counting. Oh. I guess this is actually, yeah, to make it closer to the original. And so what we want to do is do that. Yes, what we have to test in the session now is we've got our partition vector and we've got our twiddled Boolean vectors as matrices. Does our magical idiom, which is first axis oriented, but I suspect this means I would have to rotate, transpose what I'm doing, which I really don't want to do if I don't have to, but we might have to. Yeah. Yeah. It's supposed to be 5. It says it's supposed to be 5. This smells like it's pretty efficient. Okay. And our last one, since we apparently have lots of different versions we were keen to try now that we've worked through the problem a bit more. Our partition vector is not just a partition vector, since we're going to be not equal scanning it by the end anyway, which looks like this. You can do it as like iota length omega, reshape each one, reshape rank 0, 1. Neg 1 plus 0. No, wait. We have p back. 1, 2, 3, 4, 5, 6. But once you not equal scans it, you only get 5. 1, 2, 3, 4, 5. Yep. Hope we're not missing. Anyway, 1, 2, 3, 4, 5. With an extra thing of zeros on the end. Yep, and we suspect that this is faster than generating the partition vector and scanning it. Okay. Then next, the last thing that we want to see if we can do. Oh, shut up. Well, that's not good. Yeah? Yeah, that's not good. We'll see what that's about. Yeah, the last thing we maybe want to do is see if we can do the twiddling without this rank loop. Really? Yeah, you can do that. No at pvec constant. Shape pvec reshape. Pvec reshape behind reshape. Kind of insane, kind of beautiful. That's our booleans. But we think it's wrong now. Slightly annoyed about that. Okay, come on. It's 2, ms3, ms4. Killed right again somehow. it just dies. It just dies under your feet, man. You become unable. It's completely unresponsive. Yeah, I know. Yeah. Quit. Yeah. Quit. Just do it again. What? Okay. Oh, because my virtual machine is chugging. What equals ns? Wonder if that helps. Not sure. Okay, so it named those. It passes all tests with the main one. Whatever bug ms not 1 and you're saying ms2 works, ms3 works. What? Oh, well, that's interesting. Yeah. Well, yeah, but we're doing this to it anyway. Okay. So if we imagine we have a boolean like that. You're telling me it's somehow different to the one that looks like that. And it's not. So we have the correct boolean. The incorrect pvec. It's no longer a partition vector once you've not scanned it. Can you really not avoid that? That's... Not if you want to use this technique. One, no, no. Yeah, that's a shame. That's fine though. What we'll do, same thing, but we can no longer use. So what's the difference then if I end up doing the same thing? Ah, this technique here. Okay, see how much that helps. Right. So partition vectors generate the same way. Getting kind of ugly, but maybe it'll be worth it. But the whole Boolean not should be better than this, where we're generating wheres and looping and stuff. Everything else should be the same. Define all 4 functions. Yep. Yep. Okay, and then I get yeah, shame about the conversion of strings to booleans. But whatever. So it's question mark 1e4 reshape 2 1 2 1 2 1 2. Is that input? Runtime minus C. They're all going to be relatively slow because my virtual machine is having a nightmare. MSI, MS2I, MS3, MS4I. Yeah. Okay. Too big. Try smaller. I wonder what's so horrendous. Partition vector generation, I guess. It's literally the worst one. No way. How is it that every optimization I've made, how every theoretical optimization I've made has actually made the performance worse? I guess because they're just so much more complicated. Well, that's so intriguing. It's really that bad? Wow. Let's see. At operator, probably a big contributor. So what would that be? That would be B gets pvec reshaping omega. Possibly a big copy there, could be expensive. B comma not XOR scan pvec compress B get flip get comma not scan pvec. Compress B, compress ravel B, not flip these, flip those, so that's just using normal replacement. Oh. Oh yeah, I sees it. Got to ravel the B there. Okay. Okay. Okay, we're back. Do we have I? Yeah, apparently. Still, I'm using at in the others. How is it so much worse? Okay, so large scale at operator with a Boolean constant matrix is oddly slow. Okay. Okay, riddle me this. MS234. Yeah. It was only a bit worse last time. And now it's a lot worse. Okay. It's a bit worse. Riddle me this. Flipping row by row, because everything else is the same, is apparently faster than, I guess it's a bunch of memory copies manifesting, that's what it is. That kind of does things in place-ish, or at least it's only copying. Yeah, that's gotta be it. Anyway, main point is, what an incredible tale of misguided micro-optimization that turned out not to matter anyway. I guess we're going to be submitting the original cleaner and faster version. I wonder what that is though. Like, I wonder why these old techniques are so much slower in this case. It's because we're dealing with matrices? Don't know. Don't especially. So, that's it. Thanks very much for watching, and I'll see you on the next one.